Hello, students. Today I'm going to make 2 videos to explain this worksheet. Okay, so I hope you have tried it because I gave you a lot of times already. So now let's take a look. Ethene dioleic acid has 2 carboxylic acid group, okay, and it can be prepared from ethene 1,2-diol. So give the reagents. Obviously, this is a primary alcohol, right? Primary alcohol upon oxidation, it will first be oxidized to aldehyde and then go all the way to carboxylic acid. Since there are 2 primary alcohols on each side, so upon oxidation, it will become dioleic acid, right? So the reagents is easy, right? The question doesn't ask you to name it, so you can use chemical symbol, acidified dichromate solution, and heat, okay? Okay, the formula of ethene dioleic acid crystal is this one to determine the number of moles of water. Okay, so basically you have what's doing right now. You use 1.09 gram of ethene dioleic acid crystal. Okay, then you make it up to 250 ml solution. Then you try to extract 25 ml out and titrate it against the standard sodium hydroxide solution. By means of standard, it means you know its molarity. So what happened? Wait. So by means of standard, you know its molarity. Its molarity given is 0.103. Okay, and then you use this amount at the end. Okay, so I think the question should ask you to calculate the value of n, right? Okay, let me see. Yeah, calculate the value of n. Okay, now let's take a look first. What happened? Okay, describe how students should prepare the, okay. Now this is a very standard question. Okay, and I think you did it in your practical as well. Basically, you have 1.09 gram of acid. Then how can you make it to 250 ml in the volumetric fast? Now, of course, you have to mention volumetric fast. So basically, the idea is you first dissolve it in around, for example, around 100 ml of distilled water, right? With stirring. Then you pour everything into the volumetric fast and then rinse the beaker several times, and then pour the rinsing into the volumetric fast as well. And then you add distilled water until the water level reaches the graduation mark, and you stop it and turn it upside down several times, then you get it. So basically, you have to recite the steps because this is also a very common question in the exam. So you can say first, dissolve, okay, the acid crystal into around 100 ml of distilled water in a beaker. Okay, then with stirring, very important. Then pour the solution into 250 ml volumetric fast. Remember to spell it correctly in the exam. Okay, and then rinse the beaker and pour the rinsing into the volumetric fast as well. Okay, then add distilled water into the volumetric fast. In the exam, of course, you have to spell it out. Don't just write we fast. Okay, add distilled water into volumetric fast till the water level reaches the graduation mark. Remember, Graduation mark is the keyword. Okay. And then stop it and turn it upside down several times. Then you will obtain the distilled water, the diluted solution. Any question? 好. Now then let's look at it. The next question will be, give the color change at the end point. Okay, color change at the end point. So basically, the titrant is sodium hydroxide, right? And the solution in the conical flask is acidic. So, and you now use phenolphthalein. So if you remember the color change at the beginning, before the titration, is acted to an acidic solution, right? The solution made from the ethene dioric acid. So the color of the phenolphthalein in acid will be colorless. And when you add alkali into it, when it reaches the endpoint, it becomes pale pink, remember? And in alkali, it is purple. So it will change from colorless to pale pink, as I said, right? Now, this is what I told you. The question should ask you the value of n, the value of n. Then we do it now, okay? Now, for you to follow the question easier, I try to do it here, okay, instead of the space provided. So basically, you have this equation given already. Then you put down the information, alkali 0.103 mole, molarity, and then the volume used is this one, right? So you're going to calculate the mole. You just have to sum them together because concentration times volume is equals to molarity. So it will be, remember to convert it to dm cube. So if you do it correctly, it's 1.6686 times 10 to the power negative 3, okay? So now since the mole ratio is 2 to 1, so if you get this mole, you should be able to work out the mole of the acid. You just have to divide this number of mole by 2. So you will get this one, you will get 8.343 times 10 to the power negative 4. Okay, now this mole is basically the mole here. Listen, the mole in this conical flask. But what's the mole? What's the total mole of the acid? Okay, because originally you have 250 ml and you extract 1/10, 25 ml out for titration. So after getting number of mole of the acid in 25 ml, if you want to work out the original number of mole of the acid in the V flask, you have to times it by 10 because you just get 1/10 out for titration, okay? So therefore, the number of mole of this thing in the sample, okay, because this solution is made from sample, right, will be this number times 10, okay? 10 is from, no, I don't want to make you confused, times 10, okay? Times 10, this 10 is from 250 ml and you extract 25 out, okay? So then you get this number times 10 to the power of negative 3, okay? 好, the question asks you to work out M, right? You have the number of mole and you have the mass. So mass over molar mass will be the mole, right? The mass is 1.09. The molar mass is here, H2C2O4 with M water, right? So 2 plus 2 times 2 carbon, 4 oxygen, plus 18 water equals to the number of mole, this number. Okay, then you only have one unknown, then you can solve N out, okay? So if you do it correctly, N will be equal to 2.25. Now, you may find that it is very weird because normally n is integer. Yes, you are right. But for this question, since the data are coming from experiments, so it's possible. Or in the exam, you can check the values again to make sure you do it correctly. Do not write off everything because it's not an integer. Sometimes it is possible because maybe the data is from the experiments, right? Maybe when you are doing the experiment, you have some human errors. Okay, so just leave it there. If you do it correctly, you should be able to get this number. Okay. Oh, and then the student thought that a thin dioxide acid crystal used may have been slightly damp, means wet. All right, wet. Explain the effect of using damp crystal on the titrant. Okay, think about if 1.09 gram of this crystal, okay, contains some water, okay, then think about the number of mole of sodium hydroxide to which the endpoint will be what? Of course, will be more than the actual one, right? Because we think that 1.09 gram is a pure acid crystal, but in fact, part of the water contributes to the mass. So, which means you need more sodium hydroxide to which the endpoint, right? Oh my word, you need less sodium hydroxide. Sorry. Let me do it again. So it contains some water, right? It contains some water, which means the exit amount, actual exit amount is decreases, right? So the number of mole of sodium hydroxide to which the endpoint will be lower, right? So, and then doing the calculation, now originally your calculation is like that. And you work out n, right? Now think about if this value is going down, and then the n will increase. Do you agree? Because you're going to switch these two parts, okay? This number will become the denominator. So if the denominator decreases, the n will increase. You can make up a number, for example, 8 times 10 to the power negative 3, and try to work out the value of n, okay? Then you will know the n will increase, okay? I explain once again, because this sample contains water inside, which means the actual exit amount is lower than expected. So the amount of sodium hydroxide that which the endpoint will be less than before, right? So this will lead to a decrease of this number because we get this number from the number of mole of sodium hydroxide, right? From the mole ratio. So if this number decreases, the n will increase because after switching the position of these two groups of number, this number will become the denominator. When for a number, when the denominator decreases, of course, n will increase. Do you understand what I'm saying? Okay, so I will make another video to explain the next question.